In Lesson 1-3, we're going to learn about midpoint and distance formulas. First, we're going to start discussing about what is a midpoint. And a midpoint is a point that divides the segment into two congruent segments. So you're going to start with a line segment. Notice here we're starting with line segment JK. And point M is the midpoint. It's a coincidence that it's M, but we often label midpoints M. You can label it anything, but it's common that we label it with the letter M. But anyway, so you're going to see that M is the midpoint, and what that means is that segment JM is going to be congruent to segment MK, okay? Because what's happening is it's going to split these two segments. It's going to split JK into two exactly equal parts, okay? JM and MK. Now, you're going to see different kinds of writing. You see here that I said segment JM is congruent to segment MK. This is talking about the segments, okay? That the individual segments, the red segment here and the blue segment here, are exactly congruent to each other. They are the same size. Now, notice this here says JM equals MK, but it doesn't have the bar on it. And what this is referring to is this is basically saying the length of JK, which is 3, equals the length of MK, which is also 3. So when we're talking about the lengths are the same size, we can say equal because we know that 3 equals 3. When we talk about two objects or segments having the same size, when we're referring to the segments themselves, then we use the word congruent. A segment bisector is another interesting term that we're going to use a lot. And anything can be a segment bisector. You can bisect something or cut something with a point, a ray, a line segment, or even a plane. But either way, whatever it is that's cutting through the segment, when it's a segment bisector, it means that it bisects it or splits it into two equal parts. So it doesn't just intersect it. No, it bisects it. It splits it into half. So if I know that this line is a segment bisector, okay, of segment AB, then I know that this point here is the midpoint, and I know that, for example, AM is now going to be the same size as MB. I've split it in half. One way that we identify a bisector is by telling you that it's a bisector. The other way that we'll tell you that something bisects another is that we'll use these little congruence marks here. And if this has a single tick mark and this has a single tick mark, then that means that they have the same length, okay? That they are equal in length and they are congruent in size, okay? So here again, this is what all this is saying. So line CD is a segment bisector of segment AB. Therefore, segment AM is congruent to segment MB, and the length of AM is going to be equal to the length of MB. So here's an example. In the skateboard design, VW bisects XY at point T. So this is the bisector, okay? And so VW right here bisects XY at point T. So that means that point T is going to be the midpoint of segment XY. And if I know that it bisects XY, I know that XT, this piece here on the left, is going to be congruent to the piece on the right. Let me do it in a different color. To YT or TY, okay? So I know those two segments are going to be congruent, and that means that the length of XT is going to equal the length of TY or YT. I probably should have done TY, but again, it doesn't really matter. Remember, order doesn't matter when you're talking about naming a segment. So I know those things to be true. So if they give me more details and they tell me that XT is 39.9, basically they're telling me that this segment right here is 39.9. they want to know what is xy. Well, let's think about that. If xt equals 39.9, ty also equals 39.9. So xy, which is both of them, is going to be 39.9 times 2, or 39.9 plus 39.9. So it's going to be 18, should be 79.8. Because we know that xy, right, segment addition postulate, right, tells us that the whole thing is equivalent to the sum of its parts. So it's going to be xt plus ty. In example 2, we have point M is the midpoint of VW. Find the length of VM. So now again, always be careful with what they're asking you. What they want is this length right here. They want to know what VM equals. All right, so if M is the midpoint, then what that's telling us is that VM, segment VM, is congruent to segment MW because it splits it in half. That means the length of VM equals the length of MW. And so I can now substitute VM equals 4x minus 1. I know that MW equals 3x plus 3. So I'm going to solve for x here, and that's going to help me figure this problem out. So I'm going to subtract 3x from both sides. That's going to leave me with x minus 1 equals 3. I'm going to add 1 to both sides, and I'm going to get x equals 4. So I know that x is 4. Now, that's an important answer that I got, but that is not the answer of what is being asked. They want to know what is the length of VM. So VM, the length, equals 4x minus 1. If x is 4, I'll sub it in 4x, and I'm going to get 16 minus 1, or 15. So VM equals 15. I can answer many more questions at this point as well. I know if VM is 15, I know MW is also going to be 15, and I know that the entire segment, VW, will be the sum of those two, or 30. But again, this is what they wanted to know, so this is all I needed to answer here. Now, the midpoint formula is a little bit challenging. Oftentimes, we want to know the midpoint of a line. However, the line is not always a vertical or a horizontal line where we can sort of figure out the midpoint by counting or using division of the length or something like that. When it's on a coordinate plane, we have ordered pairs that we have to work with. And so it makes it a little bit more challenging. So this diagram is super confusing, okay? They're basically saying here that point A is identified as some x value and this y value, so x1 and y1. This point B is identified by another x value and a different y value, so they call that x2 and y2. And they basically tell you that using that, the formula for the midpoint is going to be this x plus this x divided by 2. That's going to give me the x value of the midpoint, and the y value will be the sum of the two y's divided by 2. So that's the coordinates here. If I were to give you real numbers, this problem would seem much easier, and that's what I'm going to do. Instead of dealing with x1 and y1 and all that weird stuff, let's just give you some values. Let's say that A is 1, 1. That's the ordered pair that goes with A. And let's say that the ordered pair that goes with B is 3, 3. So basically, we've got A equals 1, 1, B equals 3, 3. Now, the midpoint, okay, the formula for that, again, is basically the average of the x's and the average of the y's. The average of the x's makes up the x coordinate. So my x's here are 1 and 3. So 1 plus 3 divided by 2. My y's are also 1 and 3. So those are 1 plus 3 divided by 2 as well. Well, this means 4 over 2. This is also 4 over 2. And 4 divided by 2 is 2 and 2. So my midpoint is going to be located at the coordinate 2, 2. So the midpoint formula is easy. You're finding coordinates for the midpoint. The x-coordinate is the average of the x's of the endpoints, and the y value of the midpoint is the average of the y's of the endpoints. Again, we'll do examples and it'll make a lot of sense. So here we go. Here they're telling us that we have this line segment RS. Okay, notice line segment starts at R and ends at S. The coordinates of R is 1, -3. The coordinates of S are 4, 2. And it wants to know what are the coordinates, what is the XY value of the midpoint of that. So again, remember that the midpoint is going to be the average of the X's and the average of the Y's. So we're going to look at our X's. Our X's are 1 and 4. So 1 plus 4 divided by 2. Our Y's are -3 and 2. So -3 plus 2 divided by 2. And now you just do the math. This is 5 over 2. And this here is -1/2. And that's the midpoint. Now, if you want, you can make this a mixed number. 5 over 2 is 2.5 and -1/2. For graphing purposes, I find it easier to use to convert to mixed numbers for graphing. But again, either answer is fine. Notice -2 or +2.5 is right here. That's my x value, and my y value is 1/2 a unit down. And here's my midpoint, and it makes sense. Whenever you find your midpoint, go back to the drawing and make sure that your coordinates make sense. So now we get to a problem which is a little trickier. Now we're getting to a problem where they give us one endpoint and the midpoint, and they ask us for the other endpoint. And that might sound a little tricky. So what they're doing is here, notice they gave us J. They said, oh, the coordinates of J are 1 and 4. The coordinates of K are unknown. We've got an X and a Y. We don't know what it is. And then they tell us that the midpoint is 2, 1. So that might be a little bit harder for you to solve, right? Now remember, how did we find the midpoint? Remember that this midpoint was identified by taking your x's and finding their average. So it would have been 1 plus x divided by 2, right? The y value of this midpoint we would have gotten by doing 4 plus y divided by 2. That would have been the setup to find that. So what happens is, if I know that this would have given me 2, I can set that up as an individual equation. I can say, okay, well, 1 plus x divided by 2 equals 2. Let me figure out what x is, right? Well, first thing I could do is multiply both sides by 2 to eliminate the denominator. 1 plus x equals 4, and then subtract 1 from both sides and get x equals 3. So guess what? X is 3. 1 plus 3 divided by 2 is going to give me 2. So guess what? The x value of point K is 3. So I just found one of the values of point K. Now I'm going to do the same thing for the y. I know that 4 plus y divided by 2 has to equal the y value of the midpoint, which is 1. So I'm going to be ready to solve this. Again, I'm going to multiply by 2. I get 4 plus y equals 2. Subtract 4 from both sides, and I get that y equals -2. And so I know that the y value of point K is -2. And so guess what? There's my endpoint K. And again, I should make sure that this makes sense. So I'm going to count. I'm going to identify 3, -2 on the graph. 1, 2, 3, 1, 2. And guess what? That's exactly where that would end. So obviously, yes, you could have looked at this and figured it out, but what we want is mathematical proof of where the endpoint lies. Okay? So you're just going to utilize that midpoint formula, and instead of finding the midpoint now, you're finding one of the unknown values in the formula. Now, the other thing that we're going to often ask you to do is we're going to ask you to find the distance between 2 points. Basically, what we're going to ask you is, what is the length of this segment? Okay, this AB segment here. Well, again, if it's a horizontal line, you can just count across the x's. If it's a vertical line, you can count across the y's. But when it's diagonal, it doesn't really work that way, right? So what we're going to have to do is try to identify, how do I know, or how can I figure out how long my line segment is? Well, again, in this example, they use the x1s and y1s and all that. What they did was they said, okay, point A here, we're going to give it an x and a y value. They did x1, y1. For point B, they gave it a different x and y value. So they call it x2, y2. And what we find is that if we do this formula, we're going to be able to solve for the distance. So notice the formula is basically saying the length of segment AB is equal to the square root of, and then notice here, x2 minus x1 squared plus y2 minus y1 squared. Well, x2 minus x1 squared is just saying x2 minus x1 is the change in x. What was the difference from one x to the other? Same thing here. What is the difference from one y to the other? And then you're going to square that difference. So how would we do this if we were given real numbers? Well, let's come back to this same problem, and let's just give A and B a value. Let's give A the value, let's give it 3, 1. Let's assume that this is 3, and let's assume that this is at 1. And this is just me saying that it's 3 and 1. So as an example, I'm going to make A 3, 1. I'm going to make B 4, 5, 6, and I'm going to make it 2, 3, 4. I'm going to make it 6, 4. And again, this is just me giving it a random value. Okay? So if A was 3, 1 and if B was 6, 4, and I wanted to find the length of segment AB, I would take the square root of, right? Now my difference of my x's, what I always do is I always write my coordinates one on top of the other. And when I'm doing my differences, I always do top minus bottom. It doesn't matter which one goes first, as long as you're consistent. So I'm going to do 3 minus 6 squared, and then when I go to my y's, I'm going to do top minus bottom, 1 minus 4, and again, I'm going to do that. So now I come over to here and just do the math. This is negative 3 squared. This is negative 3 squared. So this is 9 plus 9. It's going to equal the square root of 18. And again, I can simplify the square root of 18. So AB, the length of AB is the square root of 18. I can simplify that. I know that this is 9 times 2, so it's 3 radical 2. Or I can plug it in my calculator and get a decimal. We're going to want simplified radicals. And so that's how we find the distance. So I know the length from A to B is going to be 3 radical 2. Now I'm going to show you some shortcuts down the road to do this, but for right now, this is the distance formula, and this is what they want you to do, okay? So now I'm going to do it again, but now it's not on a graph. Now I'm not going to have to graph it or anything like that. I'm just going to be able to find the distance between 2 points by using the formula. Again, remember that I kind of write them with 1 point on top of the other. So A on top, B on the bottom. And then I know that the length of AB is going to equal the square root, and it's going to be the difference of my x's squared plus the difference of my y's squared. So my x's, I'm going to go down 13 minus 7. And my y's, I'm going to do 2 minus 10. So again, I come over to here. I have 13 minus 7 is 6. So I have 6 squared. 2 minus 10 is negative 8 squared. When I do the math, I get 36 plus 64, square root of 100, which we all know the square root of 100 is 10. So the length of segment AB equals 10 units. Okay? When I go to CD, same thing. So C, I'm going to put D underneath it, 4, negative 1 like that. and then I'm going to find the length of CD. So it's going to be the square root of, it's going to be the difference of my x's, 2 minus 4 squared, plus the difference of my y's, 3 minus negative 1 squared. So when I do my math here, this is going to be negative 2 squared plus, it's going to be 4 squared. So this is going to be 4 plus 16, or the square root of 20. Now, the square root of 20 can be simplified. 20 is 4 times 5, which means I can take out the square root of 4, which is 2. So the length of CD is 2 times the square root of 5. Okay? If you give me the answer as the square root of 20, you would lose some points because that is not fully simplified. However, you would get the bulk of the credit. Okay? And then 2 radical 5, and obviously if you have your calculator, you would be able to come up with a decimal for this answer. But we really don't want decimals most of the time. We want simplified radicals like this. Okay? And that's it. Now you might say, well, you did top to bottom and you did 13 and 7. Does the order matter? Well, let me just show you really quickly. If I did it in the opposite order, let me show you how my answer would still be the same. I mean, we already know that AB is 10, right? So let me just do the same problem and let me switch the order, okay? So what if I did B and A differently? Let's say I did it this way, right? So the segment, I know the segment length would be, again, the difference of my x's, so 7 minus 13 squared, plus the difference of my y's, 10 minus 2 squared. So the last time, here we had a positive 6 squared and we had a negative 8 squared. Notice now what we've got is a negative 6 squared, and this time the 8 is positive and it's squared. In the end, though, once we square this, the negative and the positives don't matter anymore. This is 36, this is 64, and again, I'm back to the square root of 100, which is 10. And so it doesn't matter whether you put the B first and subtract the A's from it, or you put the A's first and subtract the B's. What matters, and the only thing that's important, is that if you're going to take this A and subtract this B from it, when you do your Y's, you've got to take this Y and subtract this one from it. You've got to go in the same order, okay? In other words, what you can't do is you can't do 13 minus 7 and then do 10 minus 2. This is what you cannot do, okay? You have to stay in order. Sometimes it may not make a difference in every problem, but you just have to be consistent with your order, okay? And that's it. That's the lesson for today. So focus on that midpoint formula, focus on the distance formula, and practice different problems with the midpoint where you're given 2 endpoints and you find the midpoint, or where you find an endpoint and a midpoint and you have to find the other endpoint. That's the most challenging problem in this assignment.